That's fine. You started?
Yeah.
You guys ready?
Yeah.
Okay. So we know already you guys have been working the a squared plus b squared equals c squared on the right triangles. And we know they can be in different shapes. Like you can have them be long and skinny, or they can be where the two legs are kind of the same. As long as a squared plus b squared equals c squared, it is a right triangle, right? Everybody's got that one? And do a bunch of problems with those?
Yeah.
Okay. But we have the special right triangles. They're called the 45, 45, 90. Okay. This is also called a isosceles right triangle. Okay. And that means the two angles are the same. They're both 45. And that means these two legs are also the same. Okay. And I know for you guys who started that investigation, where you did figure out a little bit of this. Okay, are you guys getting this in your notes?
Yeah.
If you're talking right now, that's not what you're supposed to do. Okay? If this was 3, okay, can you guys tell me what is the other leg?
3.
Everybody on the count of 3, tell me what it is?
3.
1, 2, okay, that'll work. And then, what about the hypotenuse though?
The hypotenuse is
Do you remember it's 3
X.
square root of 2? Okay. That there's a pattern on this special triangle that the two legs are the same, and this is always the hypotenuse is always the length of the leg times the square root of 2. So if this instead was, grab an eraser. If this instead was 17, okay, what would the hypotenuse be? 17 square root of 2. Okay? And that pattern always happens, and the other leg has to be 17. So we can say that the hypotenuse on this one, this special right triangle, is going to be the square root of 2 times the leg. And both legs are the same, so we could talk about that being the same. Okay? So, do you guys kind of get that from before?
Yeah.
Did you see that from the couple of problems from the homework?
Yes.
Okay, go ahead and pause it. Okay, so we have this other special right triangle. So out of all the right triangles, this whole class of special ones called the 30, 60, 90 triangles. The 30 degrees is opposite the shortest leg. Okay, the 60 degrees opposite the longer leg, and the right angle is again opposite the hypotenuse. Okay, that's how we can define which one is which. We're going to see there's a special relationship between these three. Okay, but to see that, I'm going to take a different triangle. If I take this triangle right here, what is this triangle called?
Equilateral.
This equilateral and equiangular. All those angles are 60. And if I split this right down the middle, what is this angle right here going to be? 30. Does everybody see that's going to be 30? So you can see we kind of made two of these special triangles, right? And so if I knew that this side right here was 10, okay, what do you think is true about this little length? Isn't it 5? Okay. And then what we could do is find on this triangle, this height, and we can talk about that being the longer leg and finding it with Pythagorean theorem, right?
Yeah.
So let's go ahead and try that. If I have x squared plus 5 squared equals 10 squared, okay, that x squared plus 25 equals 100, and x squared equals 75. Do you guys see how I did the subtraction
Yeah.
to get x squared by itself?
Yeah.
And then x is going to be the square root of 75. Now this radical right here can be reduced, and it's going to help us see the pattern if I reduce it. Okay? So if I break that down, I can see that that is the square root of 25 times the square root of 3. Okay? So if I have those two, okay, one of these ones can actually get out of the radical.
These are the law day schedules. You need to hand these out before this period or either right now.
During second period?
Yes, no.
So the square root of 25, what do you think?
5.
That's going to be 5. And then radical 3. Okay? So if this is 5, this right here is 5 radical 3. And this one is 10. that's going to show us that there is a special relationship no matter what the length of the short leg was. Okay, we're going to see that if I have a 30, 60, 90 triangle, here's our 60, here's our 30, here's the right angle, that if this one was, say, 16, then the hypotenuse is always going to be twice as big. So it would be 32. And then this one, the long leg, is 16 times the square root of 3. And so what's great is even though we did Pythagorean theorem here, this is a shortcut to kind of help us solve these things out without having to do this again. Okay? So I want you to see that. I'm going to write that in words, and we'll say on this one, the hypotenuse is 2 times the short leg. Okay? So like this leg right here, if I knew this was 20, this would be 40. Okay? And that the long leg, which is this one right here, would be the square root of 3 times the short leg. And this goes both ways. So if I knew the long leg, I could find the short leg. Or if I knew the hypotenuse, I could divide by 2 to get the short leg. Okay? And you're going to see, hopefully, some of those problems in a moment.